When you hear the name Babylon, what comes to mind? The Hanging Gardens? The Tower of Babel? Perhaps images of ancient ziggurats piercing the Mesopotamian sky? For centuries, Babylon has captivated our imagination as one of history's most legendary cities, but here's what's remarkable. In just the past few years, archaeologists, linguists, and historians have uncovered discoveries that are rewriting what we thought we knew about this ancient marvel. We're talking about recently translated cuneiform tablets that reveal advanced astronomical calculations, new archaeological evidence about the city's true extent, and insights into Babylonian science that were centuries ahead of their time. So grab your coffee, settle in, because we're about to journey back 4,000 years to one of the most sophisticated civilizations the world has ever known. Let's start with some context. Babylon, located in modern-day Iraq, about 85 kilometers south of Baghdad, was already ancient when Alexander the Great died there in 323 BCE. But for centuries after its decline, the city became legend, a name remembered in biblical texts and classical sources, but its physical location lost to time. It wasn't until the 1800s that European archaeologists began seriously excavating the site. Robert Koldewey's German expedition, from 1899 to 1917, uncovered massive structures, including the Ishtar Gate and the foundations of what might have been Nebuchadnezzar's palace. But here's what's fascinating. Even after more than a century of excavation, we've only scratched the surface. Recent satellite imaging and ground-penetrating radar have revealed that the ancient city was far larger than previously believed. In 2021, a joint Iraqi international team announced findings suggesting Babylon's urban area extended over 10 square kilometers during its peak under Nebuchadnezzar II. That's roughly 1,500 football fields. Entire neighborhoods remain unexcavated beneath the desert sand. And there's good news. After decades of conflict and neglect, serious conservation efforts resumed in 2019 when Babylon was designated a UNESCO World Heritage Site. This has allowed archaeologists to return with modern technology, and what they're finding is extraordinary. Now let's talk about one of the most exciting areas of recent discovery: Babylonian astronomy. And this is where things get really interesting. For years, scholars have known that Babylonian astronomers were skilled observers of the heavens. But tablets translated within the last decade have revealed something extraordinary. The Babylonians were using sophisticated mathematical techniques to track planetary motion that wouldn't be reinvented in Europe until the 14th century. Nearly 2,000 years later, in 2016, Professor Mathieu Ossendriver from Humboldt University published a groundbreaking study. He had deciphered 4 Babylonian tablets dating from 350 to 50 BCE that tracked Jupiter's motion using what we now call geometric calculations. They were calculating the distance Jupiter traveled across the sky by computing the area under a time-velocity graph. Think about that for a moment. This is calculus-level thinking, the kind of abstract mathematical reasoning that we credit to medieval European scholars at Oxford and Paris in the 1300s. Except the Babylonians were doing it 1,500 years earlier. The tablets show they divided Jupiter's 60-day journey into 2 sections and calculated the time needed to travel the first section using what's essentially the trapezoid rule from integral calculus. This wasn't just practical astronomy for calendar keeping, this was abstract mathematical thinking applied to celestial mechanics. But here's where Babylonian astronomy intersects with something you might recognize: astrology. Now, before we go further, let's be clear about the distinction. Babylonian astronomers were conducting empirical science, carefully observing, recording, and predicting celestial events with remarkable accuracy. Their astronomical diaries, kept for centuries, tracked everything from lunar eclipses to planetary positions. However, they also practiced astrology, the belief that celestial events could predict earthly affairs. They created horoscopes, believed in auspicious and inauspicious times, and developed an elaborate system connecting celestial patterns to human events. In fact, the Babylonians are credited with developing the zodiac system that later influenced Greek and Roman astrology, and eventually spread worldwide. Recent translations of tablets from the British Museum and other collections have revealed extensive mathematical tables the Babylonians used for these calculations. We're talking about tablets containing hundreds of astronomical parameters, tables of lunar and solar positions, eclipse predictions spanning decades, and numerical constants calculated to remarkable precision. One particularly fascinating discovery involves their goal year texts. These were administrative astronomical tablets that collected past observations to predict future events. Scholars have recently realized these texts weren't just for calendar purposes. They were sophisticated predictive models used for both astronomical forecasting and astrological prognostication. The Babylonians used a base 60 number system, which is why we still have 60 minutes in an hour and 360 degrees in a circle. Their mathematical tablets show they could calculate square roots, solve quadratic equations, and work with what we'd call Pythagorean triples, all in service of understanding the cosmos. Let's shift from the tablets to the stones. What recent archaeology is revealing about Babylon as a physical place. You've probably seen images of the stunning blue-glazed Ishtar Gate with its golden lions and dragons. But that gate, now reconstructed in Berlin's Pergamon Museum, was just one of 8 massive gates that pierced Babylon's walls. Recent excavations have revealed much more about the city's incredible infrastructure. In 2020, Iraqi archaeologists working in partnership with international teams announced findings about Babylon's water management system. We knew the city had sophisticated canal networks. After all, this is where the legendary Hanging Gardens were supposedly located, but new excavations have uncovered an even more complex system of underground channels, cisterns, and what appear to be pressure-regulated water distribution systems. They've found clay pipes with precisely engineered joints, settling tanks for water purification, and evidence of hydraulic engineering that wouldn't be matched until Roman times. One structure, tentatively identified as part of a palace complex, shows evidence of rooftop gardens with advanced irrigation, which has reignited the debate about whether the Hanging Gardens actually existed and where they might have been located. Then there's the Etemenanki, the great ziggurat of Babylon, which many scholars believe inspired the biblical story of the Tower of Babel. While only foundations remain today, recent analysis of brick stamps and architectural fragments has allowed researchers to create more accurate reconstructions. A 2022 study combined archaeological evidence with descriptions from ancient sources like Herodotus and determined the ziggurat likely stood about 91 meters tall, roughly the height of a modern 30-story building. It had 7 levels, each painted a different color, with a temple to Marduk, Babylon's patron god, at the summit. But perhaps most exciting are discoveries about how ordinary Babylonians lived. Excavations in residential areas have uncovered homes with remarkable features: built-in clay ovens, drainage systems, even what appear to be early bathing facilities. Tablets found in these homes reveal business contracts, school exercises, medical texts, and personal letters, giving us an intimate view of daily life. One particularly charming find was a collection of school tablets showing a student practicing cuneiform writing. The teacher's corrections are still visible on the clay. These tablets included not just writing practice, but mathematical problems, astronomical tables, and mythological texts, showing that education in Babylon was quite comprehensive. Recent excavations have also identified what appears to be a major marketplace district. They found standardized weights and measures, storage facilities for grain and goods, and tablets recording transactions using early forms of credit and even interest-bearing loans. Babylon was a sophisticated commercial center where merchants from across the ancient world came to trade. Medical texts from Babylon, recently re-examined and translated with better understanding, show that Babylonian physicians practiced systematic diagnosis. They categorized symptoms, prescribed treatments based on observed effectiveness, and kept detailed records of patient outcomes. While they certainly mixed medicine with magic and prayer, they were also conducting what we'd recognize as empirical medical practice. One fascinating tablet, translated in 2018, contains what's essentially a differential diagnosis chart. If the patient has these symptoms, it might be this condition. If those symptoms, it might be that condition. This is rational medicine, not pure superstition. Their mathematics was equally impressive. Beyond the astronomical calculations we discussed earlier, Babylonian mathematicians tackled abstract problems for the joy of problem-solving. Tablets show they worked on algebraic problems, calculated compound interest, and even explored number theory. But let's return to astronomy and what scholars are now calling Babylonian proto-science. Recent studies of astronomical diaries, daily records of celestial observations kept for centuries, show that Babylonian astronomers were doing more than just recording. They were analyzing patterns, testing predictions, and refining their models when observations didn't match expectations. Their eclipse predictions were remarkably accurate. Using centuries of accumulated observations, they developed the Saros cycle, a period of about 18 years and 11 days after which eclipses repeat. This allowed them to predict both lunar and solar eclipses with impressive precision. They mapped the stars, identifying constellations and tracking the movements of the 5 visible planets, which they named after their gods. Jupiter was Marduk, Venus was Ishtar, Mars was Nergal, Mercury was Nabu, and Saturn was Ninurta. These associations between planets and deities would later influence Greek and Roman mythology, which is why we still use similar names today. One of the most important astronomical texts is the Enuma Anu Enlil, a massive series of at least 70 tablets containing thousands of celestial omens. Recent translations show this wasn't just superstition, it was systematic correlation. The Babylonians observed that certain celestial events preceded certain earthly events, and they recorded these correlations meticulously. Now, did the stars actually cause those earthly events? That's where astronomy and astrology diverge. The Babylonians believed they did, that the gods communicated through celestial signs. Modern science tells us correlation doesn't equal causation. But here's what's remarkable: in their attempt to read the heavens for divine messages, the Babylonians developed rigorous observational and mathematical methods that laid the groundwork for modern astronomy. Another critical text, the MUL.APIN Astronomical Compendium, has been the subject of intensive recent study. It contains star lists, information about the zodiac, and methods for tracking the sun's motion through the year. Scholars now recognize it as one of the foundational texts of ancient astronomy, influencing astronomical traditions across the ancient world. Now, here's something crucial to understand. This astronomical knowledge wasn't just academic, it was sacred, and it was controlled by a specialized class of priests. Recent research has revealed that Babylonian priests, particularly those serving in the temples of Marduk and other major deities, functioned as the primary astronomers and keepers of celestial knowledge. These weren't just religious figures performing rituals. They were highly trained scholars who spent their entire lives mastering complex mathematical and observational techniques. Tablets recently translated from temple archives show that young priests underwent rigorous training that could last decades. They had to memorize vast catalogues of celestial omens, master sophisticated mathematical tables, and learn to operate observational instruments. Some temples maintained rooftop observatories where priests conducted nightly watches, meticulously recording the positions of planets, the phases of the moon, and atmospheric phenomena like halos and eclipses. What's particularly fascinating is that this priestly astronomical knowledge was considered a form of divine revelation. The priests believed they were reading the will of the gods written in the heavens. This created a unique situation where religious devotion drove scientific precision. They had to be accurate in their observations and calculations because they believed they were interpreting messages from Marduk himself. The king relied on these priestly astronomers for critical decisions about warfare, agriculture, and state ceremonies, all timed according to celestial events. Recent studies of administrative texts show that successful astronomical priests held considerable political power and were among the most respected members of Babylonian society. They advised kings, managed temple resources, and formed an intellectual elite that preserved and transmitted knowledge across generations. In many ways, they were the ancient world's first professional scientists, even though they would have understood their work through an entirely religious framework. So why does all this matter? Why should we care about tablets covered in wedge-shaped marks written 2,500 years ago? Because Babylon's intellectual legacy shaped the world we live in today. When Alexander the Great conquered Babylon in 331 BCE, Greek scholars gained access to centuries of Babylonian astronomical observations and mathematical texts. These were eagerly studied, translated, and incorporated into Greek science. The great astronomer Hipparchus, working in the 2nd century BCE, explicitly acknowledged using Babylonian observations to improve his own celestial models. Later, during the Islamic Golden Age, scholars in Baghdad, located not far from ancient Babylon, preserved and built upon this knowledge. They translated Greek texts that had incorporated Babylonian learning, created new astronomical tables, and developed algebra, a word that comes from Arabic al-jabar. This knowledge then traveled to medieval Europe, where it influenced the development of modern astronomy. When Copernicus proposed his heliocentric model, and when Kepler calculated planetary orbits, they were building on a foundation that stretched back through Islamic scholarship, Greek science, and ultimately to Babylonian observations. Even today we use Babylonian innovations. Our 60-minute hour, our 360-degree circle, our base 60 subdivisions of time and angle, these come from Babylon. The zodiac signs used in astrology, Babylonian in origin. The 7-day week ultimately derived from Babylonian associations between days and celestial bodies. But Babylon's legacy faces challenges. The site suffered damage during recent conflicts in Iraq, and parts of the ancient city were damaged by military installations. The push to preserve and study what remains has become urgent. Fortunately, modern technology is helping. Digital humanities projects are creating 3D scans of tablets, allowing scholars worldwide to study texts without traveling to museums. Machine learning is being applied to help decipher damaged or unclear cuneiform. And international cooperation has brought together Iraqi scholars with colleagues globally to protect and study this heritage. Just last year, Iraqi archaeologists announced plans for new excavations in previously unexplored areas of the site. With improved security and UNESCO World Heritage status, there's optimism that the next decade will bring even more discoveries. So where does this leave us? What have we learned about Babylon from these latest discoveries? First, we've learned that the Babylonians were far more scientifically sophisticated than we previously understood. They weren't just recording the sky, they were analyzing it with mathematical rigor that wouldn't be seen again for centuries. Second, we've learned that the city itself was larger, more complex, and more technologically advanced than earlier excavations revealed. The infrastructure, architecture, and urban planning of Babylon represents one of humanity's great achievements. Third, we've gained a deeper appreciation for how Babylonian knowledge shaped the course of human history. The direct line from Babylonian astronomical observations to modern astrophysics runs through every major civilization between then and now. But perhaps most importantly, we've learned that there's still so much we don't know. Thousands of tablets remain untranslated in museum collections. Vast areas of the ancient city remain unexcavated. Every new discovery seems to raise more questions than it answers, and that's exactly what makes this so exciting. Babylon isn't just ancient history gathering dust in museums. It's a living field of research where new discoveries are constantly changing our understanding of humanity's intellectual heritage. If you enjoyed this deep dive into Babylonian discoveries, please hit that like button and subscribe for more ancient history content. We've got videos coming up on ancient Egypt's mathematical papyri, Chinese astronomical records, and the astronomical knowledge of the Maya. Drop a comment below what aspect of Babylon fascinates you most: the astronomy, the engineering, the daily life of ancient Babylonians, and what ancient civilization should we cover next? Thanks for watching, and remember, the past isn't dead. Archaeologists and scholars are literally digging it up and rewriting it as we speak. Until next time, keep exploring history.